The subcapacity reporting tool then produces a report based on this data, which is sent to IBM, who in turn uses the report to calculate the customer software invoice. Here's an example for one LPAR. The graphic shows the rolling 4-hour average of MS utilization for the LPAR over the course of a month. In hour 3, the workloads running on this LPAR produce a rolling 4-hour average of 542 MSUs, which is the highest rolling 4-hour average for the month. Even though each subsystem running on the LPAR has an individual contribution that is only a fraction of the peak, ZOS, IMS, DB2, and CACS, which are all running on the LPAR, will be charged at 542 MSUs. Most environments have more than one LPAR, and calculating the peak rolling 4-hour average becomes more complex with each additional one. The subcapacity rolling 4-hour average is calculated based on the combined rolling 4-hour averages for all the LPARs where a product is running. In this example, even though LPAR 1 has a peak rolling 4-hour average of 542 MSUs in interval 3, and LPAR 2 has a peak of 455 MSUs in interval 720, the peaks are not simply added together to get the aggregate. Instead, the aggregate peak is calculated as the combined rolling 4-hour average for the two LPARs. So for example, in interval 1, the rolling 4-hour average is calculated as 915 MSUs. That's 480 MSUs from LPAR 1, 435 MSUs for LPAR 2. This combined peak is then calculated for each interval across the entire month. The peak is then determined as the highest combined rolling 4-hour average. In this case, that is 923 in interval 720. IBM will now bill this customer using 923 MSUs as the basis for the products running on the two LPARs. It is interesting to note that IMS does not use much CPU resources throughout the month, only about 7% of the peak rolling 4-hour average. Yet due to the high cost of IMS, it will account for 35% of the total software expense. This example highlights the big challenge associated with the subcapacity model. Here's an example of an SCRT report. As you can see, it only reports on the peak rolling 4-hour average for each individual product and does not provide much information otherwise. The SCRT is, after all, a billing tool and not meant to be planning, modeling, or helping you to understand your MLC costs. BMC's Cost Analyzer for Z Enterprise takes the guesswork out of determining your MLC cost drivers. With 100% rolling 4-hour average visibility, workload awareness, and cost awareness, it can help you determine how your environmental setup contributes to the MLC cost and identify areas which can be improved to help you lower costs. Once areas for potential improvements are identified, Cost Analyzer allows you to model how changes in your environment will affect the workloads and the bottom line monthly cost. The what-if analysis capability helps to reduce the expenditures of IT actions, which may not result in lowering MLC spend. Additionally, contract management will help you keep track of the MLC spend historically, compare each month to budgeted amounts, and forecast what the spend may look like in future months if changes are not made. Utilizing these tools for your cost analysis provides you with the knowledge of your costs and workloads so you can make cost-effective plans for your environment. Now that we understand why CAzE is important, let's take a look at its architecture. Architecturally, Cost Analyzer consists of three pieces. The Universal Information Exchange Component, also known as UE. UE executes on the mainframe to read and process SMF, RMF, and CMF records, plus subsystem data to populate the capacity management databases, or CDBs. The CDB application server manages the databases that are populated by the UE data for use as input into the CAzE cost model build process. The CAzE application server is installed on the Windows server and retrieves the data from the CDB to build the models. The CAzE interface is then accessed via a web browser of your choice. Reference the CAzE user guide for a complete list of software and browser requirements. The Universal Information Exchange, or UE component, processes the listed SMF records. SMF 30, subtypes 1 through 5, 70, 72 subtype 3, and 89 subtypes 1 and 2 records are all required for all the LPARs in the environment and for all the CPCs that you're using. It is also recommended to include the control cards for the No89 products. No89 products are the MLC products that do not produce SMF 89 records and are passed to the IBM SCRT report separately via the No89 DD statement and the SCRT JCL. The UE job should be scheduled to run on a regular basis to ensure CAzE is being populated with data in a timely fashion. The CDB application server, which manages the database, is a Windows server. The operating systems supported are the 64-bit versions of Windows Server 2012 and 2008. The capacity management database utilized by CAzE to store data can either be SQL or Oracle. The supported versions are SQL 2008, 12, 16, and the Oracle versions are 11.1, 11.2, and 12.1. Additionally, the following features need to be enabled: .NET Framework, Message Queuing Server, and Internet Information Systems with ASP.NET, and WCF HTTP activation enabled. A minimum of 8 gigabytes of memory is required for the server. Once the cost analyzer components have been implemented, it's time to access the solution. The first step is the signing on. Use a web browser of your choice to access CAzE. Navigate to the CAzE URL that was created during installation. The URL address is the host server where CAzE is installed. When the splash dialog is displayed, click the Sign On icon to enter the appropriate credentials. You will log on to CAzE using the user ID and password provided to you by your CAzE administrator. Access to the various functionality in CAzE is determined by which user group your ID has been assigned. After logging in, the Cost Analyzer console is displayed. The Cost Analyzer console consists of various tabs and clickable buttons to navigate through CAze's functionality. In the upper left-hand corner are the tool tabs. Software Contract Reporting tab, which is the summary report based on budgeted, actual, and projected costs. Monthly Reporting tab, an individual month summary of costs and workloads. And the Planning tab, which is used to create and evaluate cost optimization plans. The toolbars are located in the upper right-hand corner. You have the Administration toolbar button, which gives access to CAzE administration functions. The ICAP configuration tool, which is used to create parameters for BMC's intelligent capping for Z Enterprise. At the bottom of the screen, on the left-hand side, are the View tabs. This shows which view or views are currently open.